Welcome to Scaling Up H2O, the podcast for water treaters by water treaters, where we're scaling up on knowledge so we don't scale up our systems. Hello, Scale It Up Nation. Trace Blackmore here, your host for Scaling Up H2O. And folks, I am so excited because we are bringing back last week's guest. Of course, last week we learned all about the history and the functionality of filming amines. Well, today we're going to be talking about how to actually use those filming amines in the systems that we encounter each and every day. Of course, my returning guest is Marodi Kabari. Marodi, how are you?
I'm well, thank you. How are you?
I'm doing wonderful. Thank you so much for spending some more time with us. I know the Scaling Up Nation has a lot of questions around filming amines. I mentioned the presentation that I did for AWT in 2018, and there were just so many people that came up to me after I did my presentation that had questions. I think we did a good job at answering a lot of those last week, but now we're going to get into the specifics of each and every system. Are you ready?
I'm ready.
All right, so we are going to use filming amines in boilers, cooling towers, and closed loops. And last week you talked a little bit about how different formulations work better in those individual systems. With that being said, let's start with the boiler. Now, I have a boiler that's on a phosphate program, and I decide that I want to change that over to a filming amine program. What do I need to know and what do I need to do?
So my answer is going to go in two different directions. If we are in a low pressure, non-critical environment, so a CNI, if we're in a hospital or if we're in an office building or a school or I don't know, pick a low pressure environment, then my answer is actually just turn the conventional chemistry off and turn your filming technology on. There's a million different types of chemistry out there. There's so many different formulations. Everybody's got niche options. For all intents and purposes, filming amines don't usually have a negative interaction with other types of boiler chemistries. However, I don't want to say it's not possible. And so easiest answer, both in practical application and economically, is turn one off, let's turn the other one on, and let's get the system turned over. The flip side of that is high pressure, high temperature, critical operating environments, right? And in that regard, I would actually refer everyone to a document. It's called it's Technical Guidance Document 8, put out by the International Association of Properties of Water and Steam. It's free and available online. They have all sorts of different technical guidance documents. But it's truly an international collaborative by the top professionals within an industry on how to apply different types of applications. So there's one specifically on filming amines. So it walks you through the process. You will learn a lot about filming amines and nomenclature, probably, more in depth of what we basically worked through last week. But then also it talks you through a bunch of different type of applications, whether it's biomass plants or nuclear facilities or, pick your favorite high temperature, high pressure environment. And it will talk you through the ins and outs of turning one chemical program off and bringing another chemical program on. In our experience, I truly believe that turning one off and turning the other on is in your best interest, especially for the majority of the AWT marketplace. But if you want more details and just to be able to think a little more critically, I would refer you to that document because I think it will be an asset to you in your understanding and application.
So when I'm disconnecting the products, so I've got my phosphate, I've got my steam line treatment, I've got my alkalinity builder, my sludge conditioner, and my sulfite. I'm disconnecting all of those and I'm replacing them with filming amines. Is that what you're saying?
With a filming amine product, yes. So one thing we didn't talk about last week when we discussed nomenclature was in referring to them, a filming amine is a molecule itself, right? So film forming amine. We also just have film formers. So sometimes you'll hear products referred to as a film forming technology, but that doesn't necessarily make it amine. And then the last part of that nomenclature is a film forming amine product. And basically what that means is it's a complete product. It's got filming amines in it as some of the material, but then there's also other materials in there, whether that's an alkalizing amine or an application specific compound. Okay. And so in the world of boilers, our cocktails are generally derived of filming amines and alkalizing amines of some combo. Pick your favorite filmers, pick your favorite alkalizers. So what's nice about a film forming amine product that was designed for a boiler application is that amines already inherently are higher pH molecules. So while the filming amines impact over pH is not as great as an alkalizing amines impact over pH, they're both inherently going to buffer to a higher pH. So that takes care of the filming amines, not only take care of your corrosion inhibitor, and then the alkalizing amines are exactly what they say they're going to do. They're going to not only neutralize pH, but then continue to drive pH up. So you're going to consume carbonic acid and just drive your pH in the system up. And then they're really, yes, the only thing we're not really mitigating at that issue is oxygen scavenger. But the thing is, remember what we talked about last week, when you form those films and nothing that's in solution can come in contact with the metal, we're not worried about specifically oxygen causing an oxygen pitting type problem. So in the simplest way of explaining it, you're truly, you're solving the problems that you would originally be mitigating with 4 different products with one product, and it happens to perform in a different way. Does that make sense?
I think that makes complete sense. Now, let's say you and I have the client-supplier relationship, and I'm now going to change my boiler over to a filming amine product. What information do you need from me to make sure that you match the right product for my need?
Sure. So first and foremost, I'm going to ask you what pressure you're running at. Second, I'm going to ask you what type of facility you're in. So if you're in a facility that is FDA sensitive, then that's going to pick a specific product. If you're in a high pressure power plant, I'm going to gravitate to high pressure options. If you're in a non-FDA low pressure environment, I'm going to direct us towards low pressure options. So really choosing a cocktail, if you will, choosing a product is really based on the system more than anything else, the needs of that facility.
Is it fair to say that most maybe AWT members are treating a specific type of boiler, and within that specific type of boiler, the specific type of conditions that we can get away with using the same product over multiple boilers?
Yeah. In my experience with our AWT teams, it's generally lower pressure. You have some pressure teams, but generally lower pressure. And it's picking one of two. Are you a low pressure environment where it's a hospital and we need to conform to the CFR? Or are you a non-CFR compliant facility? And so it's really usually one or the other.
All right. So now we've got the right product there. We've decided that we're going to go ahead and just take away all of our formal chemistry, and now we're going to replace that with our new film forming amine product. What do I need to expect? And now maybe we talk about 3 different scenarios. So now I have a boiler that's fine. I just want to change the product. Or maybe I'm trying to clean up something like scale or corrosion. What do I need to look for with those?
Sure. So first thing I tell people to do is system inventory. Make sure you know what you're getting yourself into. Do you have a really old boiler and we're going in to solve a problem? Right? If so, what's your problem? Are you having issues? So understanding if we're trying to solve a problem, if it's just that you've been working with filming amines, you like them and you think that this would be a suitable facility for application of film forming amine product, and there's really no issues, we're just switching it over, then okay, that's fine. I like to refer to identifying our objectives as key performance indicators. What are our markers for success going to be? If it's that we're solving a problem, if we have iron issues, then eliminating that iron issue, that's a performance indicator. If we're having pH management issues, that's a performance indicator. Water loss. Go through any of the different scenarios that you could and identify what your objectives are for your chemical change, right? Why are we doing this? And what do we expect and want and or need to see? So, and then really go in and do a systems inventory. what's the state of this boiler? Is it something that I've been caring for a period of time and I'm familiar with? And so I know what my challenges are and what to expect. Is it a system that I'm inheriting? And maybe it's been really well cared for, maybe it hasn't. But what roadblocks could I potentially be up against? And I say that because with any chemical regime change, there's going to potentially be upsets, right? Maybe there will be, maybe there won't be, but knowing what you're getting into ahead of time helps you, one, communicate with your customer, your end user, so that they know what to expect in all of this. Ultimately, you're doing a service to them, right? If there's an issue, let's say it's a scale issue, right? Let's say you have a really scaled situation. There's a boiler that has inherently struggled with softener upsets. And over time, you just have a calcium scale buildup. Okay, well, we can go in and we can constructively work to clean that out. But we all know with scale deposition like that, there's potential for underdeposit corrosion, right? It's not necessarily that it's there or to what degree it's there, but that it's possible that it's going to be there. How bad is it going to be? Nobody knows until we clean it off, right? But you have an end user and they're asking you for heat transfer reasons to get this cleaned up and cleaned out. Okay, so that's fine. But what do you need to be prepared for? Well, with underdeposit corrosion, depending on how bad the corrosion is, we could potentially see pinholes. If you had active corrosion cells in there and you go in and you clean them out and that corrosion transcends a pipe, then you could potentially see a leak. Like if this is, and again, this is not unique to filming technology. It's just a reality of the situation. So knowing what you're going into as you're taking something over, as you're cleaning a system out is vital, in my opinion. So those are the kinds of things I would pay attention to. What's your water quality? I mean, do you have softeners? Do your softeners function? Are you on RO? Or are you in a state? Are you in a location where you really don't struggle with calcium hardness issues? So there's not that treatment there. But just knowing the facility, knowing water usage, how much water are they using? Is there a meter? Is there a makeup meter available to you? Those are all types of questions that I ask going into it so that we can constructively move forward with a plan and have markers for success as we move through the process.
Marodi, is there a specific limit if you don't have a water softener, how much calcium or total hardness you want to hold in the system?
Honestly, I don't have an answer for that one. And it's a crummy answer. I get that, but here's where it comes from. Truly, we work coast to coast, north to south. And in some scenarios, we have people with relatively hard, moderate, I guess we could say moderate hardness, where softeners maybe go in and out of working and they apply filming amines and we haven't seen any issues where there hasn't been any redeposition or growing deposition of scale. There's been facilities where we've had a softener go and we ended up seeing a deposition of calcium carbonate scale. The truth of the matter is, especially in the world of boilers, my preference is always going to be that there be pretreatment. And I say that not just as a plug for all my softener people and all RO people out there, but because calcium carbonates have that inverse thermal relationship regarding solubility, right? And so pre-treating a system is just minimizing risk long-term. What we do know with filming amines, what I've seen time and time again, is that with the application of filming amines, whether you're in a boiler or whether you're in a cooling tower or even in a closed circuit type environment, is that with the application of filming amines, if we see deposition, calcium or other types of deposition, you can see deposit in like low flow areas, but it deposits in a non-adherent form. Like there is a modification of the scaling ions and they may lay down just because of a flow delay or slowing, whatever you want to call it, change, but they don't stick. And when I say they don't stick, I truly mean when I've seen them, I can wipe them off with my hand. Sometimes they're really soft and fluffy. Sometimes they are a little bit harder, but the scale doesn't really hold together. And the slightest bit of mechanical application, i.e. my small Carmi hand, and they disappear. They rub right off. So can we deal with calcium upsets? Yes. To what degree can we deal with them? It really depends on the location and the area. The easiest way is to just prevent them from the beginning, right? Try and just pre-treat and then not deal with the issue at all. But I mean, I get that that's probably not an answer that everyone would love to have. But if anyone feels inclined to go through a design of experiments with me, I'd be happy to engage.
Well, we'll definitely talk afterwards. In Atlanta, we have extremely soft water, and some people translate that into they do not need water softener. Folks, I'm here to tell you, I've been in the business for a very long time. My father was in the business before I was. And if you're going to have a boiler, just because of the nature of the beast, start with better water quality. And a water softener is just something that can hedge so many bets. And then if you have a chemistry that works even better than some other chemistry, that's just going to make you more successful. So you and I didn't answer that question for each other, but I think we gave them enough information that they can figure out what they need to do. Well, Mary, I want to get into now that we are going to feed this product. So how do we feed it, and where is the best place to feed it?
Okay, so my preference is to feed it into a makeup line, whether that's a manifold going into the boiler, whether it has to go into a holding tank first, a day tank. I mean, there's, you all know, you've been in so many different facilities. Every setup's a little bit different. Ultimately, my preference would be for it to go into a manifold if it needs to, or just through its own line into the boiler. And I want to dose the system, if you will, based on makeup water. So if you can put a meter on your makeup, that's preferential for application. One, for just knowing exactly how much you're using, but two, to really be able to hone in what's really needed. So meter on your makeup, I want it going into a line and then into your boiler. But I can tell you, we have people where like that's not an option. And so it goes into a DA tank, or it goes into a holding tank. We kind of have to go wherever our options are. What you need to know is that the filming amines do exactly what we've discussed. They clean out and then they film. So if you go into your DA tank first, you're going to see movement, potential remobilization of whatever loose corrosion debris you have, if whatever, and then that's going to move. We got to be ready to get that out of there. And then it's going to slowly but surely work its way through the system. It's going to progress, from your DA into your boiler, up into your steam lines, and then back around.
So would you suggest if the only place you can feed is in a feed water or DA tank, and you know that it is fouled, maybe it's a little corroded, we can expect that there's going to be some cleaning. Do we maybe waste some of that water in the initial process? Is there a way around that, or do we just have to deal with it?
If you can, if it is an option to let it circulate and then drain it out, I mean, my preference is always just to get the crud out, truly. The nice thing about boilers and cooling towers is that they're constantly, there's a bleed, there's a flushing system built into how they function. And in the beginning, when you first bring these things online and it goes through this cleaning process, it's got to get out of there. So blow it down, blow it down, blow it down. Blow down your mud drum extra if it's possible. I mean, you can go ahead and either leave your conductivity set point for your surface blow down, or you can lower it just a little bit if you want to, but just get it out. Blow it down, bleed it off, whatever you want to call it, but get it out of there. Because ultimately, what leaving loose debris does is leaves increased surface area in there. Then all of a sudden, there's even more like little niche space for the filming amines to go. And I don't want them to go onto debris that we're going to blow down that we don't want in there. I want them to go onto your pipes. I want them to go on the surfaces that we have a goal for coating. So I don't want to use up the material or the filmers, if you will, on a spot that ultimately I want to go down the drain.
I love that explanation. It makes perfect sense. I always tell my customers when I'm trying to explain that chemical is lazy, and if it can get to something quicker than where we actually want it to go, that's where it's going to go. So if we can get all that free stuff out, we're just going to have more available filming amine product to go where we want it to go.
And like a caveat to that is if the optics with your customer are such that, let's say they come to you and they're like, well, we know we have a scaled system and we have a boiler inspection in 2 months and we want it to look better. Do you have something to clean it out? Well, the filming amines will work, but will they work in 2 months so that optically you look like a hero? Maybe, maybe not. So if you have a situation where you're heavily scaled, then maybe doing an acid cleaning ahead of time and just getting it out to begin with, right? Clean it off, clear it out to begin with, and then going in with your filmer to go in and scrub the rest and film the system over and protect the metals. It's just going to accelerate your rate of success, right? So when we think through this process and the application of filming amines, don't completely erase, even though I told you to turn one set of chemistry on, turn another set of chemistry on or off and then on, you still have all of your other tools available to you. So making sure that we focus and have a well-rounded approach is still important here.
No, we don't need to forget everything that we know about water treatment just simply because we're changing chemistries, loud and clear.
For sure.
So let me ask this. Ideally, we want it going into the feed water line close to the boiler, so it sees that first, or going directly into the boiler if we can do that through manifold. If we can't do that, and let's say we can't, so now we're feeding into a feed water tank, and then ideally we're metering off of the makeup, so we have a metered amount of filming amine product that's going into the system. Let's say we don't have a water meter. How do we feed it then, or is that not the right product then?
Well, we do have people feed it without a water meter. We basically do a series of calculations based on, okay, how much water are you using a day? We can look at the horsepower of the system, what we think the volume of the system is. We can look at condensate return rate, whether we can, they know the condensate return rate, or do we have to measure and then calculate that? There are calculations that we can do that can get us relatively close to a makeup rate. It's not perfect. It's not my favorite way of doing it, but it is possible to do. And then basically based on a series of calculations and then either best case scenarios or assumptions, right? Whether it runs 100% all the time, or if it runs 70% of its capacity, or if it runs 60% of its capacity, we can do a series of calculations that enable us to make a best guess, and then we can dose based on that. And then ultimately, something that we didn't talk about last week, but I think we can touch on here if it works, is that the question of how do we know if we've properly dosed a system, right? The nice thing, or what we're used to, I say it's a nice thing, it's just what we're used to about conventional oxygen scavengers, say, is that we have a pretty well-established program for measuring oxygen, metering an oxygen scavenger, and then if there's X residual of oxygen scavenger, then we feel pretty comfortable saying, okay, we've consumed the oxygen in the system, we shouldn't be at risk for oxygen pitting. Well, the same type of phenomenon happens here in understanding whether or not we've appropriately treated the surface area of a system. So we have X surface area in a system, doesn't matter how much. How do we know if all of that surface area is coated? Well, the answer to that is actually the same as the answer to the oxygen scavenger question, is there a residual? Is there a residual of the chemical left? So if there's a residual oxygen scavenger, we say, we've consumed all of the oxygen in a system. If there's residual filming amine in a system, then we say, we've coated all of the surface area in a system. So in the world of dosing without a meter, we can do the math, and then we would just monitor for filming amine residual in specific locations so that we could say, okay, well, in here, we seem to be dosing appropriately. We've got a healthy residual. We have no iron, right? There's no corrosion actively occurring, and we've got a decent pH. Okay, we're covered. We're good.
There you go. I think there is a lot of confusion around that though. So now I'm an old school water treater. I'm used to treating boilers and having multiple parameters that I can identify to see if the program is going properly. An example is like the one you gave. I can check for sulfite. I can check for my phosphate. I can check for the amine and the steam line treatment. I can check for how much polymer if I want to run that. So I've got all these different checks that I can run because I'm putting all these different products in. Now that I'm taking those products away and I'm replacing it with my filming amine product, I have I think it's the rose bin gal method that a lot of people use, but basically it's just a color test. And if it turns the right color, we know that we have available filming amine in the system, but we don't have all those other tests. So for somebody that likes to see a bunch of tests just to know what's going on in the system, what advice can you give me?
So my answer is actually kind of twofold. My first response are, okay, so you can measure all of those things. In a conventional program, you can measure polymer, you can measure sulfite, pick them all, you can measure them all. But what's your ultimate marker for success?
You open that boiler up and it looks good.
It looks good. Or you pay attention to your iron levels. It's corrosion rate. That's ultimately our marker for are we doing well, is what's the corrosion rate in that system. Or if you open it up, does it look good? Is it clean? Right? So I can measure a polymer loading until the cows come home. And so, okay, what does that tell me? It tells me a polymer level. It doesn't necessarily tell me how well something is doing. What I really care about is corrosion rate. The same thing is true for filming amines. Okay? So that's one piece. Is like, let's look at our ultimate key performance indicator. Let's look at how are we marking success? Are we marking it by saying, okay, I can do 10 different tests and then I can show that I've done 10 different tests? Or are we looking at it based on what really matters? In my mind, that's corrosion rate. The other piece of that is that testing for residual of filming amine is truly no different than testing for residual, like I said, of a different product. I mean, you're ultimately doing the same thing. But rather than me tell you, I need you to test 4 different products because you're putting 4 different products in there, I'm telling you, you're putting this one item in there, and I want you to test for this item. It's essentially the same thing. We're still just looking for residual. It's just, is there residual left in solution because ions in solution have been consumed, or is there residual left in solution because surface area has been consumed? It's the same thing. It's apples and apples. And I think what throws people off is that it's 4-to-1. Like we just bumped down how many things we were testing. And I think that it just kind of weirds people out.
No, I think that's a very good point. I used to be able to test all these things, so I think I'm getting better information, but I think you said it very well. I'm getting the information that I need to run the type of program that I'm running.
And ultimately, our marker is lack of corrosion, right? So if we're monitoring, if we care about iron, we're just picking iron, if we care about iron and we have no iron, then we're successful regardless of the program that we're running, regardless of the other tests that we can do. Okay, let me caveat this. I don't want people to be like, if I use filming amines, I only have to run one test. It's not necessarily the case. I like to look at systems, any type of system, with a little bit more of a holistic approach. So first and foremost, I do care what my iron levels are, or whatever my metal of interest is, copper, iron, aluminum, whatever. I care about my metal. I care about my pH still. That's still relevant. I would still, in a perfect world, I would like it to be within a specific range. I care about how much chemistry I'm using. I care about what my water clarity looks like. Am I clear? Am I colorless? So it's still looking at a system for the overall health of the system. It's just that in the world of residual testing, instead of testing the 4 that we're used to, we're just testing the 1. But we're still looking at all of the other pieces. They're still relevant.
Where should we be taking our tests from, or should we be running multiple tests?
Well, you can do a few different sites. Partly that's based on mechanical availability, and partly that's based on limitations of the residual tests themselves. My preference is to look for residual at your furthest point from application. So my preference would be in a condensate return line with a sample cooler. And I'll tell you why. Because if we have chemistry loading into a boiler or a makeup tank or a holding tank or a DA, whatever, if we have it on that, if application's on that end, it is an all volatile treatment. We're going to go in and we're going to film and maintain pH from the point of application all the way till the point that it returns. Well, if I look for residual and iron and pH, right? That's my little trifecta that I really, really care about. If I look for those items at the furthest point and I have no metal and I have a healthy pH and I have a residual, then I feel comfortable saying that we have filmed all of the surface area up to the point of sampling. And I wish I could say it went off without a hitch 100% of the time, every time. In some systems, for whatever reason, sometimes we end up never seeing a residual. And honestly, I can't answer why, but we have no iron. Our iron levels are essentially non-existent. So my pH is good, my iron is good, I don't have a residual. In a perfect world, I'd get all three and it'd be a hat trick, but I have no iron, so I'm happy. In some systems, we get it and it's hot pink at that point. And why it is with some and why it isn't with others, honestly, there's a whole slew of potential scenarios there that we could go through, whether it was steam consumption or that we're just still, there's some dead legs somewhere that we've just continued to work at and chip away at and chip away at and chip away at. And because that area is there, we've yet to see a residual, right? But ultimately, we have no metal. Our corrosion rates look good, so we're happy. So that's my preference in point of sampling and looking at, have we fully coated a system? The reason that I say sample coolers are a best friend is two reasons. First and foremost, it's a safety issue. And I know half of you are laughing at me right now. You're like, oh my gosh, lady, if I could only get my customer to put on a sample cooler. Just remember that hands, you really only get the two. And I just don't want you to burn yourself. It's just a safety issue.
Totally get it. And thank you for the public service announcement. I think they should come as a requirement with every boiler because we're dealing with a lot of these things and they're hot. It just makes sense. So thank you for saying that.
That's part of it is, take care of your hands. You only get the one set. The other piece is that we're talking about volatile chemistry. So if you catch a hot sample that's like steamy as you're catching it, the potential for loss of what you're actually looking for is there. And the test, for one of the limitations of the test is that it needs to be cooled for you to actually be able to run the samples. They have to cool down. So if you have an open container and it's allowed to sit there and vent and cool off so that you don't burn your hands and so that your test will function, there is potential for loss there of what you're actually looking for. Maybe you have residual and maybe it's just all vaporized off. There's a level of control and elimination of variables that is my preference to observe. And that is one of them, is that you'll be able to catch cooled samples. Ultimately, what you'll do, too, is you'll film your sample cooler. You'll protect your sample cooler. Anyway, so that's my preference there. And the reality is catching a sample, speaking limitations of the test, catching a sample with the tests that are currently available directly out of a boiler is beyond the limits of those tests. And so if chemistry was just added, right, let's say it just made up and so chemistry was just added and you grab a sample out of there and you look at it and you're like, oh man, I'm hot pink. Awesome. I'm awesome. I don't want you to have a false sense of security over what the whole rest of your system looks like and then think to yourself, I can just turn this down, right? I can turn my chemical pump down. Okay, well, yeah, at that particular point, at that particular moment, it looked like you had a lot. You just dumped a bunch in there. However, fast forward to later in the day and your boiler has been running and your filmers have been filming and going up into your steam lines and performing the functions that we now understand them to perform. Maybe you catch a boiler sample and it looks like there's nothing in there. And you think, oh my gosh, I need to turn my pump up. Well, maybe. But what is your system filmed? Is there iron in your system? Maybe you don't need to turn your pump up. It's just that it's already gone and done its job. So the other piece is that often we just get, if people catch out of boilers, we just get over and able to read numbers because it's just beyond the range of what the test is capable of, or the tests, plural, are capable of measuring. Does that make sense?
It makes perfect sense. And I know you and I had a discussion after my presentation at the 2018 convention when I did my paper on filming amine products in a closed loop system, and we touched a little bit on cooling towers. But the big part of my paper, I think, was how to actually use the tests. And if you look at, and there are what, 5 different manufacturers at least that are making these amine tests. And so depending on which one you use, I've really found that I can get different answers within the same test, just depending on how I tested it, how long I waited, whether I use plastic, whether I use glass. So I want to talk with you a little bit around the test limitations, but then also get your opinion on what I've come up with is I kind of use it as a go, no-go, rather than I have this many parts per million in the system.
Sure. So my advice as a chemist, as someone that helps all different types of teams from all different walks of life, is pick a method. Pick a method and go with it. We have to control as many variables, again, as possible. So if you have a team of individuals and everybody has a DR 900, then that's going to be our method. We're going to go with it. We're going to put together a really basic, simple sampling procedure so that everybody's catching the same types of samples. Everybody's using exactly what you said. Pick a glassware. I don't care what you want to use, but pick one and go with it. Because what that allows not just your vendors to do as far as helping with troubleshooting, but also allows the people that you said, the guys that are coming up with the different testing methodologies, is it will provide them an adequate sample size and a known sampling method, within a certain team or within a certain set of teams, that they can make analytical decisions on how to improve their. If everybody on the planet does it a different way, and some guys use glass and some guys use Nalgene's and some guys use Teflon and some guys cap them and some guys don't, and sometimes it's hot and sometimes it's cold, and just pick every available scenario under the sun. All it does is leave us sitting there going, well, 60% of the time it works every time. And I don't feel like that helps any of us functionally move forward. So pick a sampling technique, have your guys use the same method, whether they use Chemetrix as test or Aquaphoenix test, or if they get a test kit from Masters. I don't care. Pick one. Have your vendor help write up a really basic sampling technique. If you don't have one, make sure you all have one. All you guys need the same thing. Everybody can execute it in the same way. And then we can start collecting information on success and failure. And if we get to a certain point where with a specific method and a specific team where it's that one's just not working, or we continue to see result X, then we can address the situation. At the end of the day, it has nothing to do with filming amines and everything to do with operation.
You're right. And I've told people it's better to be consistently wrong than not consistent.
Sure, because what it allows us to do then is figure out an avenue of change to find a better option.
No, that's a great point. So I think we've covered a lot about boilers, but we did skip over a section that I'd like to go back to. So we're now getting ready to put the chemistry on. So is there a difference between the final part per million that needs to be in the system and the initial dosage?
There's a couple of ways we can approach dosing. And really, it depends on the experience that the water treater has with filming amines, right? And it depends on when you do that system inventory, when you determine your KPIs in the beginning and what we're getting ourselves into in this process. It depends on really those items, okay? So my initial mantra for everyone who is new to filming amines or I should say, has a known fouled system is slow and low. Your vendor's going to give you a target dose. I'm going to make up numbers for easy math. Let's say that target dose is 1,000 parts per million. And at 1,000 parts per million, we feel comfortable saying in 90% of the situations, 90% of boilers at 1,000 parts per million of product, that we can effectively treat an entire system. When you first bring the chemistry on, when you turn the one set of pumps off and turn on your filming amine product pump, my advice in a known fouled system, or if you're new to filming technology, is cut that in half. Cut that down to 500 parts per million, because it's going to do exactly what we've discussed. It's going to remobilize corrosion material. It's going to start picking at scales. All of that's going to come off. And what we don't want to have happen is for that to, all of that to move into like a steam trap or a low flow area or an elbow, or pick something and then just sit there, right? We don't want to move so much so fast that the rate of remobilization supersedes the rate that we can blow it down and get it out of a system. So that comes to the other point in our slow and low mantra, and that is blow it down, blow it down, blow it down. You got to get it out of there. It's good what we're doing, but we don't want to, just like I said, we don't want to just leave extra surface area in there. It's exactly that. We don't want to leave that in there. We don't want interactions occurring where we don't want them. We want it to clean and film surfaces. So blow it down and start at half. If it's an extraordinarily messy system, I would say even cut it in a fourth. So I'd say maybe start at 250 parts per million. If our 1,000 parts per million scenario is still holding, right? Start at 250. And what you're going to watch, even with all your extra blowdown, is you're going to watch your iron or your metal of interest. You're going to watch it climb, right? So you're going to have done a baseline measurement of whatever your iron rate is at that moment before you start the chemistry on. And then you're going to turn it on to either 50% of your theoretical loading, or you're going to turn it on to a quarter of your theoretical loading, and you're going to watch your iron climb. You're going to watch it climb, you're going to watch it climb, and you're going to watch it climb, and you're going to call your vendor and say, what gives? How is this happening? And they're going to say, take a deep breath. It's going to be fine. I'll hold your hand. I promise.
And sometimes you do need to hold water treaters' hands. That stuff is scary.
It is scary. And I have to tell you, as a vendor, being however many miles away, with as much experience as I have with this stuff, even though I trust it, there's a part of me that never wants to put anyone in a position where they could potentially look bad. I don't ever want to hear a call where they're like, I need you to talk to my end user because they're freaking out on me, right? I don't want that for you. So preparing you and then preparing your end user for the clean out process is vital. Just communicate with them. Just talk to them. Let them know what's coming. And your vendor should be happy and willing to walk in there with you and communicate as well, right? Nobody should send you in there alone if need be. So you're going to watch your iron level climb, and we're just going to hold steady with that dosing rate. And then we're going to blow it down, blow it down, blow it down. And then we're going to start to watch the water clear up. We're going to watch the iron level start to drop. And as it starts to drop, as our iron numbers improve, we're actually going to increase our dose. So if we were at a quarter of the theoretical loading at 250 parts of product, we're going to bump to 500. Or if we were sitting happy at 500 and we start to see the iron number come down, we're going to bump to 1,000. Okay. And when that happens, we may or may not see another blip in iron, and we may or may not see another bit of a jump. Typically, what we see is just our iron level continues to drop, and it drops and it drops and it drops and it drops and it drops, and until ultimately we reach some sort of asymptote, right? We level off. In a magical world, it would just go to nothing, which honestly we've seen quite a few times. So when that point hits, right, when we've hit our theoretical dose and we have no iron in our system, we start looking at other parameters. We start looking for, okay, do we see a residual yet? Maybe you will, maybe you won't, but start looking. What's our pH? Have we stabilized our pH? Have we stabilized our iron? Here's the deal. So all the while through this process and bringing it on slow and low, we're not just going to bring it on and then completely walk away. We're going to have whatever our key performance indicators are. As you go back and do your service monthly, as we go through this clean out process, and then ultimately, and I know we'll talk about in a minute, into like a more maintenance phase of operating, track all these things. Track the iron. What does your water quality look like? Are you clear and colorless? Did you turn into coffee grounds? And then did you return back to clear and colorless? Were you looking like carrot juice and then got to clear and colorless? Like, just track it over time so that you have, one, markers for success for yourself, but two, you have markers for success that you can share with your customer. to show them, no, look, I understand, that this doesn't look as great at the moment, but look at what we're actually doing. Look at the direction that we're progressing in. So that's my slow and low, how we operate. Your other option, if it's brand new or truly you're in a really clean environment, you know the system that you're in, you know how it's operating, and you've got a really strong handle on the water chemistry there, and you just want to switch to filming amines because that's, you're trying to work on the profitability of the account or whatever, pick your favorite reason. Then if you feel comfortable hitting it harder, starting in at the theoretical dose, you may have to initially spend a little bit more time at that facility, but hitting it hard in the beginning. And then ultimately what you'll see is just a rate of turnover faster, as long as we don't mobilize too much too fast.
That's all great advice. I can tell you the first time I used a filming amine product, it was several years ago. We didn't have a lot of information out about it. Somebody asked me to try this. It was a brand new system, but there was a lot of flash rusting that went on inside it. So we put the product in at the maximum level because that's what we were told to do. And I really thought we just purchased that customer's boiler. I was so upset. That boiler, it went from red to black. I mean, it was just horrible. And then in about 3 days' time, it went crystal clear. We did exactly what you said. We were blowing down. And today, I mean, that's probably been 8 years. That boiler looks pristine.
Yeah, which is what we see. But I do respect and fully grasp the fact that when you first bring it on and you see something like that and it is new to you, that moment of terror where you're like, what have I done? And all I can say is you're totally normal. That everyone, I cannot tell you how many people I've spoken with, how many different teams I've spoken with. They're like, the first time we did it, we thought, oh gosh, this was a terrible decision, But now they're like, now we understand what we're getting into, and this is normal. It's very status quo. There's an unfamiliarity in change or in the unknown, and that inherently makes people uncomfortable.
Absolutely. Marodi, are there any systems or any conditions that you know of that you would say, you know what, you don't want to use this product for that?
Ooh, if your corrosion is truly kind of holding the system together, this is probably not a good fit, because the filming amines really don't care. They will just continue to scrub whatever loose debris they can until they get to a surface that they want to stay attached to. And we could end up with a problem. If you are in a once through system, unless we are solving a problem, right? Unless we're saving someone a pump every couple of years that they were having to repurchase. So unless there's some sort of issue that we can really fix, I would say once through systems are, with filming technology, expensive. So for a program that's running well and your corrosion rates are good, but you don't really have a great return, I would say that this is maybe not your best option. Really, in a boiler, those are my two biggies.
Well, Marodi, we have just spoken so much around boilers. This has been such a great conversation. I know that the Scaling Up Nation is more educated about filming amine products and boilers than they have ever been before. So thank you so much for all of the examples you gave, all the information that you gave. But I feel like I kind of lied to the audience in the beginning. I said this was the conclusion of our show. I want to bring you back for another week so we can talk about other systems like cooling towers and closed loop systems. Are you good for that?
I'm ready when you are. Ready.
All right. Well, thank you so much for spending so much time with the Scaling Up Nation. And Scaling Up Nation, we will come back next week for our final. It has to be our final one. I know it's going to be our final one because I'm not going to spend any more of Marodi's time. Thank you so much again for all the time that you're spending. So Scaling Up Nation, we will catch you next week on Scaling Up H2O.